this is our talk about how we were using Flight to leverage frictionless upgrades. And this is a generic title, but picture this. We have 600 employees doing data workflows in different teams in the company. And for some reason or another, they're using some tasks they need to upgrade. So this is our dilemma. It has been a pain for us to do it in our previous orchestration tooling. And I will present how we're using Flight to facilitate those tasks. Okay, let's talk. This is a Spotify. Maybe you already know this is a streaming company. We have in hundreds of markets in the world. We serve music and recommendations to desktop, mobile, tablets, and so on. We are one of the biggest in the business of streaming music. And who am I? I'm Nelson Arapé. I'm originally from Venezuela, living in Sweden for 9 years maybe now. I am senior software engineer at Spotify. When being here at Spotify, my time, I would say, has been divided evenly between working on the Spotify event delivery system, and now I'm working on the team that does scheduling and orchestration of data pipeline. Our team, a few years ago, we selected Flight, our next orchestration tooling, and we wrote a blog post about that. You can take a look on that link. It's in our engineering blog. And we have been working in Flight. We contributed Flight in Java and Scala. We did also a lot of work to make Flight work on GCP, at least at the beginning, and we also have done small things here and there. So what is our agenda? I will explain more details why doing frictionless upgrade is a big deal for us, Spotify. Then I will explain how we have been doing those upgrades with Luigi. This is, although we are using Flight, the migration path will be long, multi-year project. So I hope we will talk more about that in maybe in a year or so when we have migrated more people to Flight. But we are not talking about that today. So we still use a lot of Luigi. I will explain how we do these upgrades with Luigi. And then I will switch to how we do it with Flight, with the features that Flight provides. So why doing frictionless upgrades are a big deal, for us at least. Spotify, some companies work this way. Let's say they have different departments, teams, tribes, whatever it's called. And usually there is a team or organization dedicated to data, and they are in charge of all the data needs in the company. So they interact with their user. What you need, I produce it. But we don't do it like that in Spotify. We distribute our engineering force on the teams they need the expertise. So let's say there is a search team, they need data engineers, so there will be a team working on that. So our teams are multidisciplinary. So we have hundreds of engineers and teams around the company, and we don't want them to reinvent the wheel every time. So we have a smaller platform organization. There are several things working there. The mission is to produce tools and services, so our engineers are more efficient when they do. We want to then be self-sufficient. We provide platform. Let's say I want this data be anonymized, and we produce a platform that, based on configuration, we provide an anonymization for that. The same, we say I want this pipeline be scheduled this many times per day, and we will provide the infrastructure to do that. So this is giving some numbers. We have more than 600 people between data engineers and data science. They produce more than 15,000 workflows that are being scheduled every day. Yeah, we have hourly, daily, some weekly, and some yearly workflows. And as a platform, we do a lot. We schedule execution, data discovery, lineage profiling, rotation, event delivery as a service. Yeah, we do a lot. So on this environment, now let me go to the mean or basic use case. As I mentioned, we try to be a self-sufficient infra. So we will have a cookie cutter template that people will say, okay, I want to create a workflow. And then with a button, they have a GHG project with this basic infra and tooling already in place. So let's say they have a workflow and they need to, the workflow have some dependency data. So we have some tasks that look into the upstream dependencies to see if they are there. For that, we have a backend service that is in charge to say, okay, the data is present or not, giving a name that this is the data you're looking for and the partition. It will tell you here the data and here is the URL. In some discussion, we have called DNS for data, for giving a name. And not only that, we have that backend service, but also we use tasks embedded in our workflows that communicate with these services. As you can imagine, these tasks will be the same for every user that want to connect to this service. So we provide these tasks as a platform task. And this is one thing we provide this, okay, look up, I want to publish data, I want to know where to write when I create my new data, where I need to write. So all these tasks, we call it platform tasks. Then we say, okay, we need to start the workflow execution. Let's say this is a data flow, or maybe it's a big query, and when the execution is done, most probably the pipeline will compute some data and we could accumulate some counters, and we want to validate those counters, like saying, okay, we are expecting this amount of data, we're expecting, we'll tolerate this amount of invalid data, whatever. So not only is the user code they need to run, we provide platform data to make the user job easier. So in this basic example, I'm counting already 5 platform teams, and this is a simplified version. We have more platform teams involved in the day-to-day workflow that we run in the company. So let me go back to this picture. So you can picture this. We have 15,000 workflows, and these workflows not only contain tasks written by the users, they contain platform tasks. These tasks written by us as a platform team, a platform org in the Spotify, and we don't write perfect code. I guess nobody does. So we need either to ship bug fixes or even better to provide new functionality. That means that we have the problem that we need to push the new version of this task through these 600 developers to reach those 15,000 workflows. This is what is a big deal for us. Our scale, we are way beyond going manually, have one-to-one interaction with developers. We need an infrastructure that helps us doing our work. So how we do upgrades of workflows in Luigi. So Luigi, let me go back, explain a little bit here, is an orchestration framework written by Spotify a long time ago, before my time joining the team. And it's based on Python. So it's all client side. There is like a server side that take care most about distributing logging, but you can run Luigi all locally without connecting to any backend. And yes, Python is very flexible. And this is what we have been doing all these years. So how we do workflows with Luigi. So the end result will be a workflow image that this is our orchestration service, sorry, our scheduling service will take. Our scheduling service said, okay, please run this image every hour or every day. So how we produce that image? Well, we have a base image, of course. That's the base image is produced by us. We have some instrumentation that we put there. We care about what operating system and so on and so on. And then Luigi being a Python library, we specify, okay, this is Luigi, this is the version, not only the Luigi, but also every platform task will be a library, because these tasks are produced by different teams. So we will collect all the version of all those teams and we will put in the requirements. And those goes into the image. And then at the end, the user code. So we have user code, and sometimes it's very small compared to all the platform functionality we are bringing into the image. And once that workflow image is built, then the version of those libraries get frozen in time, get deployed to our orchestration scheduling system, and that's it. So why this is a problem? I already hinted. We build Docker images, and those Python versions or those versions of those libraries get frozen. So doing any upgrade involves doing a pull request to that repository to bump the library that people are referencing in their build, in their requirements. And then the problem is the scale. How we contact 600 developers to do that? Yeah, we can send emails, Slack communication, but this is one scale. And what we do is we send automated pull requests. So is this enough? It's not enough. So I haven't computed what percentage, but many developers ignore the pull request. And yeah, this is, we are reaching other people's teams. They have their own priorities. Maybe these workflows they are not working on that, or maybe they will replace that with something else soon. So they don't see the need to spend time on upgrading a platform task. Upgrading a platform that for them is not a priority. They want to deliver value. If it's running, why should I care? And some other thing, the data is critical enough. They have complex testing requirements. So they don't want to mesh any automated PR. They want to do their sandbox with control inputs and output and make sure that data they produce is the same as the one running in production. But okay, that's understandable, but there is also a problem. And this problem is that in Luigi, the tasks are really libraries. And those platform tasks are complicated. They have complex dependencies. For example, they need gRPC to talk to a backend service. So they use Google Cloud libraries because they need to do, I don't know, submit jobs to BigQuery or whatever. And maybe they're forced to bump their dependency. Maybe the BigQuery interface is deprecating this version and you need to bump, and that at the end could create conflict between different teams with their dependencies. And it's not easy to detect those. It's not easy to have a testing infrastructure that are able to catch all these possible collisions. So the sad part is that some users are hesitant to merge this PR because they're afraid that their workflow will fail in production because these dependencies collision. So we can trace that how Luigi works by tasks being shipped as libraries. There is no isolation between these tasks. Cool. So yeah, the end result is we have a reduced feature penetration. We release a version and we don't know, we will know some will merge, some will not. Yeah, we have different, sometimes we see a pipeline that is several versions behind, and yeah, that's the sub story with Luigi. So when we were selecting a new orchestration system, we really want to solve this problem. We don't want to, I mean, we know these fat clients with libraries is not something we can continue doing at this scale. And we select Flight because of that. So how we are organized? So we say, okay, it will be easier if we create a centralized platform project. We call it Flight Warehouse. Sometimes we became creative with naming, and Flight Warehouse sounds like, oh, very good because you have all the spare parts of your planes for flight. But then, of course, it sometimes confuse people with data warehouse itself. In any case, it's a platform project. So in this platform project, we centralize all the platform tasks. So now instead of being libraries that people will install in their repos, we have tasks in these projects. So all are the concentrates. And by being all concentrated in this project, then it's easier to grant permission to other people in the cookie cutter. We say, okay, you will need permission to read and pull in the artifacts of these projects. So having that makes us easier to manage the scale. And then we leverage the remote task. So we ship now a library with remote task reference. So this library is really a thin library. It's only dependent on Flyte. There is no conflict because we are not pulling in gRPC or anything. It's just a reference to task. And why we do this? Because we find easier for our user to say, okay, I import this library, this task, and they don't need to care to which project is they're looking for or which version. We will talk about version a little bit later. So this thin library doesn't have the same troubles as Luigi because it's only a remote task reference. Of course, as a bonus, Flight is language agnostic, but this is unrelated to how we do upgrades. And so we have a centralized project, we do remote tasks, and we cannot talk about easy upgrades without talking about Propeller plugins. This is, I would say, one key feature that we saw on Flight, the extensibility of Flight. And yeah, right now we are running 2 custom Propeller plugins, one related to Flink clusters and other related to doing BigQuery calls. And between both, just look up quickly, and we have done more than 40 upgrades of those plugins. And meaning that we deploy a new version of the plugin. And yeah, because everything in the backend is 100% coverage, no user intervention. And yes, this is sadly what we want. Sadly, is that not the whole story. More than 60% of our tasks are not plugin tasks. Yeah, it's harder to write a task as a backend plugin that just use Flyte Flykit or Flykit Java to write tasks in Python or Java or Scala. So in our case, we have more than 60% of tasks as a container task, meaning that, yeah, we need to do something else. And what we do is that, yes, we say, okay, let's explore this option. Let's say that, or during build time, we have a pull request. During build time, we have our theme library actually fetch what is the latest version of this remote task in Flight. And then we fetch that version and we wire up in the workflow, and then we register workflow. So on every build time, say that again, I will fetch what is the latest version of the remote task for this specific task, and then make my workflow use that. Okay, there is a trade-off. First is key that platform teams make sure that tasks are always backward compatible. Key here is the interface, that they cannot add willy-nilly any new parameter to their task. And also, users need to be aware that will relinquish control of which specific version they are using in their workflows. So they will say, okay, I will do this lookup task, and you guarantee that your interface will be stable, that won't break my code, and then under that condition, I will relinquish control and let you tell me what version to use. So a downside is that we still need to build pipelines periodically, but we have a different project is taking that. But now the key difference here is that these automated PRs, I will explain that later, are easy on users. And let's talk about this. So yes, I mentioned that platform developers need to maintain backward compatibility. But sometimes someday will be the time that breakage will need to happen. And the vision, what we say, okay, how we make possible to create a new version of the task without being a new version of the task, right? And the solution is that we do like major version in the name of the task itself. So you can imagine that platform task A v1 will become platform task A v2. That will keep the fetch latest contract still happening, because I will still be able to fetch the last version of platform task A v1, right? And I will retrieve whatever the latest version it is. Then it will be that the question, okay, then are you telling me that you are going to, every time a new version, you are going to keep maintaining more and more tasks? Sorry. Okay, Google, eso no era para ti. Bad timing of, yeah, bad timing of my Google Assistant. Okay, so we don't want to do that. We want to deprecate for removal the old names. And the way we are planning to do that is that we were able to control for how long we are allowing these two parallel versions to be alive at the same time. And because workflows in Flight I can inspect what tasks they're using, we will be able to notice that these workflow users are using the old name or the old version. And we could then send notifications, send automatic PRs to those. This is a process that we haven't deprecated any yet. So I guess when the time comes, this is our plan, and we will tell you later how it went. So this is the end of my presentation, and I will want to do a recap. why frictionless upgrades is important for us is because we have a decentralized organization and the scale that we manage. We produce platform tasks, and we need to ship features or bug fixes to those platform tasks, and those people related to all those workflows. Luigi model is not good for us. Shipping flat libraries is not scalable. The versions are frozen at build time, and developers are hesitant to merge their PRs. And a big part of that is that they're afraid of version colliding because they're fat libraries. With Fly, we use remote tasks. So we take advantage of the tasks running in isolation, one from the other, and everything we have in a common centralized project. And with the combination of Propeller plugins plus fetching the latest version of that task, this is how we decide to go with upgrading our users. What we want is to have the Propeller plugin version for everything, but we know that is probably not feasible, and we find this fetch latest with the process how to handle breaking the interface and doing upgrades is how we hope to work with this. Thank you, all of you, and I open for questions if you have any.
Oh, that was an awesome presentation, actually. Yeah, when you read it this way, it makes it even more impactful to understand why we built it. Because when we built it, we had the same problem with machine learning libraries specifically. They're really, really terrible. Like, if you import TensorFlow and PyTorch in the same, you're kind of almost dead. In the container side bloats up and things like that, and then GPU dependencies and so on. So we built it using that, but we found that within data, so there were lots of use cases for this. So it's great to see that you guys are seeing value. One thing I noticed in your thing was the two things I wanted to add. One was the deprecation or version management for tasks, and I call it interface evolution, right? And this is a common problem in any RPC or REST or any services, right? We have the same problem. Once you publish a service API, you have to live with it. But we do get some interface evolution with the service API, at least depending on the protocol that you use. And so thank you for Latch's recent work on union support. I don't know if you've seen that, Nelson. But
no, I haven't.
They just added it a month ago. So you can, we haven't yet enabled it in the platform, but we would love to work with you guys and see. We can now introduce new attributes to a task or new parameters to a task, which are of union. And the union can be optional. You can union, like one of the subtypes of union is optional. So you can say none value or an actual value, and we can make that optional value be auto substituted by the platform as none. And then users can handle, or platform builders can handle none as a default, and use the right operation for that none. And that's actually pretty, because of Latch now, it's pretty easy to do. So we should be able to do that. So thank you.
Great. It's yeah, that will reduce a lot the need of have to come up with a new
task version. Yeah.
Task with a V2 because we're able to add these attributes.
Yep. And this will be done by the compiler at compile time itself. So no runtime errors. So that's like another advantage. But yeah, we would love to work with you on that. I think this is pretty easy to do at the moment. Another one was backend plugins. We There's a bunch of work, at least in Union, that's happening for like keeping the backend plugins, but decoupling it from Propeller, like in a way that it can kind of spawn it out like services. Yet you get the same flexibility of the backend plugin. And I think Guillaume and probably Nelson, you and I also have had a chat about this in the past.
Yeah.
Closer to getting that, and we would love to see. And one advantage of that potentially is that writing them will become simpler in a way that you will have a predictable, simple API. So let's see if we would love to collaborate on that as well. But this is fantastic stuff. So thank you.
Cool.